All right. So, good afternoon, everyone. I'm Jacob. With me is Frankie, and our last groupmate Dom could not make it today, but we are the wireless sensor network for humidity monitoring project. So, real quick, what we're going to go over today, we're going to show you a little bit about the team, give you the project overview, our goals, some specifications, as well as parts and materials. Then we'll go into a little bit more specifics like system architecture and some potential applications. And then we're going to wrap it up with some future direction and a summary of our project. So I guess I'll start off with myself. I'm Jacob, and I'm currently a senior electrical engineering student at TCNJ. I'm the president of Men's Club Volleyball and the secretary of Club Robotics. I'm also a member of Theta Tau, the professional engineering fraternity, and I'm currently searching for a job in preferably the power industry.
My name is Francisco Mesa. I'm a senior computer engineering student at TCNJ. I'm a member of the robotics and also a member of Theta Tau, professional engineering fraternity. And I'm currently interested in the software development, computer engineering. And then Dom's not here, but Dominic is a senior electrical student at TCNJ with a high interest in renewable energy. And he is the president of TCNJ Ski and Snowboard Club and a member of Theta Tau and Phi Alpha Delta.
So, a little overview of the project. We're going to design and implement a wireless sensor network for humidity and temperature monitoring as well. The system could consist of several components, including Arduinos, Zigbees, that include IEEE standards, also has batteries and sensors to actually get the temperature and humidity. This network will ultimately be constructed with data sensing nodes, a sync node, and a data receiving / processing unit. So you have your nodes where you take in data. You have a coordinator that takes in all the multiple data points, kind of averages them out, or just takes in all the data, processes it, and then it gets sent up to a data receiving center where it can display the results to a user.
Our goals for this project is to develop a fully wireless humidity monitoring system. It's going to use sensor nodes to detect and record levels of humidity in the air. It also does temperature. The coordinator is going to sample the records of humidity and data temperature from the other sensor nodes and transmit it to the data receiving, which is just basically a laptop or computer with LabVIEW. It's going to be a minimum power consumption for cost effectiveness and efficiency. It's going to use Zigbee with IEEE 802.15.4 standards. And yeah.
So some specifications here. Based on our components here, we have a temperature range from -40 degrees to 125 degrees Celsius. And the humidity range also is a bit more constrained, coming from 20% to 95% humidity. As well, in addition to that, there's air in those calculations. So whatever temperature is displayed, it could be over or under 0.5 degrees Celsius. And the displayed humidity can also be plus or minus 2%. To power the nodes, we're going to have 9-volt batteries that pretty much go into the Arduino, and that Arduino then disperses that electricity into the rest of the components. Our Zigbees have 180 feet of range, and they're designed to measure humidity and temperature within one room. So if a room is about 180 feet in diameter, at least, then it should be fine. And lastly, our update time through our Zigbees is 2 seconds. So every 2 seconds, we get new data points to update the data.
The parts that we need for this are 5 breadboards, 5 Arduino Unos, 5 Zigbees, 3D DHT22 sensors, that's our humidity sensors, and 9-volt batteries, 4 of them, PC with LabVIEW, just normal circuit components like wires, a breadboard, and LED. For the LED is going to be for an alarm system that we're going to set up in the future, and it's just going to say whether whether a certain humidity or temperature is above or below like the value that we need. Here are the LabVIEW schematics and visuals that this is what we have so far, and this is what it's going to look like. On the left side, you could see like the actual gauges and the thermometer, and the bottom two graphs just show like humidity versus time and temperature versus time, and it's just going to update live like as it's being used. And the right side is the actual circuit components. This is all made by Dom, and to probably display all this temperature humidity values out on the left. Here's our project architecture. It's going to be 3 sensor nodes going to a coordinated block going to the data receiving center. And here's for the sensor nodes, each sensor node is going to have the humidity sensor and a power supply going to the Arduino. And then the Arduino is going to go to the Zigbee. The Zigbee is going to send out the information to the coordinator block right here. This is only going to have a power supply, an Arduino Uno, and a Zigbee. It's not going to contain a DHT sensor because it's supposed to be receiving all the data from the other 3 sensor nodes. And here's the data receiving center. It's going to be the Zigbee to the Arduino to the PC with LabVIEW.
So going into some potential applications here, our main application that we believe this would be useful for would be a laboratory setting. So whether it's a biology lab or a chemistry lab or even a computer lab, etc., you pretty much have to have that room within a certain range of temperature or humidity. So this system would be ideal to measure and just gauge those 2 data points within a room. Some other applications could also be HVAC and food processing, as well as medical environments such as surgical rooms. And once again, these are potential applications because all of these require a certain temperature and humidity. You don't want food to be in warm weather because then it'll go bad. Or in a surgical room, you don't want there to be too much humidity because that can mess with the equipment in there. So yeah. And moving forwards into the future, we still have to finish the project, but all of our nodes are currently built except for one. This is because we're waiting on a part, and the coordinator block has also been successfully communicating and working as expected, so that's good. If time permits, as Francisco mentioned earlier, we plan to implement an alarm system using an LED or potentially a speaker. We're still going to have to test a little bit. And pretty much what this is going to do is we're going to send a signal. In this case, the LED is going to turn on, and it's going to send that signal to the user if the temperature, humidity reaches a level too high or too low. And that could be a very applicable use for our project because at the end of the day, you're not going to have a user sitting in front of a computer just looking at temperature and humidity the whole day. But finally, an additional feature that could also be created as a stretch goal for home usage, for example, would be a power saving mode. This would save money on electricity and also make the system more efficient overall by not producing as much strain on everything.
I think that's it.
Okay, so are there questions? I know there was one, if you look at the chat.
Yes. Oh, that was just Dr. Adebege.
Okay, you didn't have any questions?
Not yet.
Okay. You know, it looks like this would be most useful in a area where, like a laboratory setting, there's a lot of applications where humidity is very sensitive. And so you'd want to keep track of that, you know, in an industrial environment or that stage. You might comment on, do you see any roadblocks or anything in completing that? Looks like you're pretty well there.
No, we actually got most of our stuff done. We just got a second sensor node working. We had an issue with a third Zigbee because of so we had to replace. Well, we're just waiting on a part replacement right now, and once that comes in, we should be able to set up the third sensor node, and then it's just like from there on, it's just a little bit of coding, and yeah, that's it. It's so we shouldn't have any more issues other than that one replacement part.
But in terms of roadblocks along the way, only problems we've really had throughout the course of this project is setting up the Zigbees. But with research and just by taking our time and being patient, we were able to resolve all issues over time.
Yep.
And your network is, I think this is an obvious question I'm asking, but is going to be accessible by the internet so that someone who's not at the control center can monitor the humidity from different locations or places?
No, it shouldn't be.
It won't be, but it's something that we could do in the future as well.
It would seem that that would be a good addition to this, to have access not from your control center, but yeah, it shouldn't be that hard a function to add.
Yeah, we'll look into it.